Now let's just move on further towards the volume of a right circular cone after doing the volume of the cylinder. So first of all, let us suppose in order to find out or in order to calculate the volume of a right circular cone, I'm just performing a certain kind of an activity over here. So let us suppose if I'm just taking a cylinder. Yes, I'm just taking a cylinder. I'm not just taking a cone. First of all, I'm just taking a cylinder and of the same radius and of the same height. Of the same radius and of the same height, I'm taking a right circular cone. I'm taking a right circular cone of the same radius and of the same height. And both of them are hollow actually. Both of them are hollow. So let us suppose if I'm just taking the radius as r, I'm just also taking the radius as r. If I'm taking the height as h, this is also the same as that of the height as h, and both of them are hollow. They are hollow. So let us suppose if I'm just filling up this right circular cone with the sand. Let us suppose if I'm just filling it up with the sand, and using this particular cone, I'm actually just filling this hollow cylinder with the sand. So let us suppose if I'm just pouring this particular right circular sand into this cylinder. So you can see that we have to perform 3 such repetitive experiments. We have to perform 3 such repetitive experiments in order to fill it up to the brim. In order to fill it up to the brim means with the help of this particular right circular cone, it requires 3 repetitive experiments in order to get filled with the sand. In order to get filled with the sand, this would require the 3 repetitive experiments, which definitely implies that the volume of the cylinder is actually 3 times as that of the volume of the cone. So from this experiment, we can conclude that the volume of the cylinder is actually nothing but 3 times as that of the cone, because this experiment requires 3 repetitive cases in which we have to fill this particular cylinder with the cone which is or with the sand which is in this particular cone. So hence this will lead us towards the volume of the right circular cone, because if this is nothing but the cone which do have a height, a radius as r, a slant height as nothing but l, so the volume of a right circular cone is nothing but of the form 1/3 into pi r square h. You can see this all by yourself over here, that the volume of the cone should be nothing but is equal to 3 will transfer to the other side. So this would be 1/3 into the volume of the cylinder. Volume of the cylinder is pi r square h. So at the end we will get the answer as 1/3 pi r square h, where pi is nothing but obviously a constant. We have the value of the pi. R is nothing but the base radius and h is nothing but the height of the cone. So always remember the volume of the cone is nothing but is equal to 1/3 pi r square h. Now using this formula, let's just use this formula in order to solve the questions which are all related with this concept.